Math 1332, Chapter 3, Symbolic Logic, Section 4, Logical Arguments, Video 2, Writing an Argument as an Implication. This is actually a really easy thing to do, and it's a necessary tool for determining the validity of an argument. In other words, for determining whether or not a conclusion would logically follow from a set of premises. Consider the following argument from the previous video. And just a note, from this point forward, all premises will be labeled P1, P2, P3, etc., based on how many premises we have. And the conclusion will be preceded by the symbol for the word therefore. In previous videos, I've mentioned that in the future, I'll formally introduce the therefore symbol. The future is now. The symbol for therefore is the three-dot triangle. And in math, it's a symbol that means we're about to draw a conclusion. So let's take a look. One of the arguments from the previous video was the following. Premise number 1. If I get a pay raise at work, then I will take my family on vacation. Premise 2. I took my family on vacation. Conclusion, and my apologies for the small font size, therefore, I got a pay raise at work. As standard in symbolic logic, we will write the premises and conclusions symbolically once we've defined the simple statements. If we let P be the simple statement, I get a pay raise at work, and Q be the simple statement, I take my family on vacation, then we can rewrite this argument as follows. Premise 1, well, it's a conditional if then. The antecedent is I get a pay raise at work, which we define to be P. The consequent, I will take my family on vacation, which is Q. Again, you have to be flexible with the verb tense. I will take my family on vacation is future tense. I take my family on vacation is present tense, but either way, it's Q. Premise 2 is a little bit easier because premise 2 is just I took my family on vacation, which was Q. Therefore, I got a pay raise at work, which was P. This is our argument written symbolically, but this is not an implication. So what is an implication? An implication for a logical argument is just a conditional whose antecedent is the conjunction of the premises and whose consequent is the conclusion. All right, let's break that down real quick. An implication is a conditional, okay, whose antecedent, the part to the left of the arrow, is the conjunction of the premises. Conjunction, meaning the word and whose consequent, the part after the arrow, is the conclusion of the argument. That sounds like a lot to swallow, but it's actually pretty easy to process. There is one, however. An implication is a conditional, but, and I have a typo here. However, to indicate that this conditional is an implication for an argument. So in other words, to indicate that the if-then statement is capturing an entire argument, we use a double line arrow like this. And again, my apologies for the small font size. So for example, let's say we're asked to write the implication for this argument, which is the argument that we wrote previously, the one at the bottom of this page in the box. Our first premise is a conditional P pointed to Q. Our second premise is a simple statement Q. Our conclusion is also a simple statement P. So how would we write this this argument as an implication? Well, first off, as an implication, it's going to have a conditional, but it's a double-lined arrow. Let's do the consequent first. That's easier. The consequent, the part that follows the arrow, is just the conclusion. So the consequent of this implication is P. But the antecedent is the conjunction of the premises. Now, I'm about to put a compound statement in as the antecedent of a conditional. Translation, I'm putting a bunch of stuff to the left of the arrow, which means it's going to go in parentheses. The antecedent is a conjunction of the premises, so let's set up a conjunction. The first premise, well, let's do the second premise second. The second premise is Q. That's easy. But notice that the first premise is a compound statement in its own right on the left side of the conjunction, and therefore will go into parentheses also. But it's really not that bad when you look at it, because it is just a conditional whose antecedent is the conjunction, whose antecedent is the conjunction of the premises, and whose conclusion, whose consequent is the conclusion of the argument. And if you think about it, it makes sense. Because what we're really asking is, must the conclusion follow if the premises are true? So, if, follow me now, if this happens and this happens, which is literally what this says, then this happens. So it kind of makes sense that an implication, one second, there we go. It kind of makes, trying to get rid of something in particular. I forgot how long ago I drew it, but this, thank you. It kind of makes sense that an implication is a conditional, because when we're talking about whether or not an argument is valid, whether or not a conclusion follows from a set of premises, what we're really asking is, if the premises are true, then will the conclusion follow? In other words, if premise 1 happens and premise 2 happens, then will the conclusion follow? Let's try another one. Well, let's generalize first. In general, if an argument consists of premises P1, P2, and P3, and there could be more than 3, and conclusion C, so we'll call it C for conclusion, then the implication for the argument is the following compound statement. The conjunction of the premises pointing to the conclusion. Notice it's very small there, but notice the double line arrow. That is just a conditional, but it's like a conditional on steroids. It's like I'm not just a conditional, I'm a conditional for the whole argument. So I get 2 lines. By the way, in the homework, if they ask you to type the conditional, they will not accept the single line, if they ask you to type the implication, they will not accept the single line arrow in place of the implication. If any of the premises are compound statements, they go in parentheses. We saw that back here. I kind of threw it in there before I warned you about it, but I thought it would be a good idea to actually write it out. If any of the premises are compound statements, they go in parentheses. So let's clean this up and take a look at another example. Write the implication for the following argument. Notice this one has 3 premises. Don't let that bother you. It doesn't change anything. Our first premise is P if and only if Q. Sorry again for the double-headed arrow being real small font size. I am trying to copy and paste some of these symbols from Word. I may go back to just using my keyboard approach for typing them. But our first premise is P if and only if Q. Our second premise is Q if and only if R. Our third premise is the negation of R. The conclusion is the negation of P. I'm not asking if it's a valid argument or an invalid argument. I'm simply asking, what would the implication be? Well, implications are easy to write. You open up a parentheses, you write the first premise, but if it's a compound statement, yes, that is a compound statement. If it's a compound statement, it goes in parentheses. So first premise, conjunction, second premise, which is also a compound statement, Q if and only if R, close parentheses. There's another premise, so we need another conjunction. Third premise is negation of R, which is not a compound statement, so we don't need parentheses around it. That concludes the conjunction of the premises. Conditional, but super conditional, so it's an implication, if you will. Conclusion, which is a negation P. Now, we haven't done a thing to determine if this is a valid argument. All we've done is take the three premises, the one conclusion, string them all together in a very long conditional. But that conditional says, if all the premises happen, then the conclusion follows. Because we're trying to answer the question, must the conclusion follow from all the premises, we're kind of asking the question, is this a true statement? Or more specifically, is this always a true statement? Meaning, must the conclusion always follow when all the premises are true? So if we could find a way to determine if that statement, that implication is always true, then we would know whether or not the conclusion necessarily follows from the premises. Well, two things. Number one, we have a name for something that's always true. And number two, we have a way for determining if this is one of those things.